Alright, welcome you guys. We're going to be talking about graphs and their models today in AP Calculus ABA. In other words, the ABA without the extra B. Okay, interesting fact. Look up some facts on ABA. Really interesting, albeit not my cup of tea when it comes to bands. Okay, graphs and their models, and we're going to finish today with talking a little bit about trig, odd or even functions, that type of thing, conversions from radians, all that stuff. So please understand this is going to be a review of trig, and then we're going to talk a little bit about the project coming up for you guys in the portfolio. All right, radian measure. Okay, so we already know. Let me do this. Okay, we already know a circle if you were to go around it, and you got to. Whenever you're talking about trig and circles, you always got to do unit circle. Okay, all right. If you were to go around in a positive direction, in other words, a counterclockwise direction, you would get degrees. Okay, and that usually was measured on rotation around the center axis. So that's the degrees part. Alright, but if you were actually to put a distance around here on a unit circle, that's where radians come into play. So radians is the distance around the circle we go. It's still comparable to degrees, except it's now a length instead of just a degree, which is just a unit of separation. Okay, and the easy conversion is to go to radians, multiply by pi divided by 180. Okay, and to go to degrees from radians, multiply by 180 divided by pi. Okay, simple as that. The pi's will cancel out or they'll add to it, and then you just reduce the fraction and just work with it that way. Okay, now graphs of trig functions. Let me get to Desmos, our good old buddy. Okay, as you can see, I'm using the same template that I was using for before. Okay, so, I'll sign in. I don't know why it always signs me out. That's weird. Okay, and we will go to trig functions, open. You guys are pretty much seeing behind. You're seeing behind the curtain. Okay, but graphs of trig functions. The red one is the sine function. Okay, it starts at 0. It continues on in this pattern. Okay, and usually, you guys, the best way to see something. The best way to see something is to just, click on the intercepts and just work with it. Now I'm going to change to steps of pi. On this one I'll change to steps of 1. There we go. Okay. Now, when you're graphing, make sure your calculator's in radians to get these graphs. If you're not in radians, it's not going to graph correctly. The great thing about Desmos is you can start to see the x-axis in terms of radians, and that's really nice in conversions. Okay. If you were a fan of degrees, tough luck. You're kind of out of luck when looking at the graph. Okay. But the red graph is actually going to be the graph of the sine. It starts at 0, goes up, goes down. Here, let me zoom out a little bit so you can see it. And here's the major intercepts for it. Oh, geez, why did it click on those ones? That's interesting. One of these ones. Okay. There we go. And so these are the major intercepts of the sine graph. The sinusoidal wave is what they call it. Okay, now if we get rid of those and we start to look at the intercepts for this one, starts at 0 at the very starts at the very top at 1, and it goes down and it just works its way across. Very interesting how it keeps giving these intercepts, and I don't want all of them. There we go. And so these are all the intercepts of the cosine that you just need to kind of have down within the first period and stuff. Okay, now tangent is you're going to be looking at a little bit differently. 0, 0. And that's it, pretty much. I mean, if you wanted to look at some, you can't really get any, but basically it just looks like this. Now you can actually adjust it and everything. So here, let me go over a little bit. So you can adjust the B, the H, those adjust the period and the phase shift. The K is the vertical shift. The A is the amplitude. If you just mess around with everything, it really kind of makes your job a whole lot easier to work with it in Desmos. Okay, so there's your graphs. You also have to remember some stuff, sine and cosine, secant, cosecant, all have periods of 2 pi. All right, and tangent and cotangent have periods of pi. Okay, so as long as you remember those ones, you should be pretty good. All right, and just remember x-intercepts, click on them on the x-axis. Mine was pretty busy, so just so you know. Let me see. Cosine and secant are even functions. Sine, cosecant, tangent, cotangent are odd functions. Okay, those ones are pretty nice, and you'll see the symmetry when you actually work around with it. Transformations, we just talked about it, phase shift, amplitude, period, vertical shift. Inverses, they're going to look a little bit different, so be careful about inverses. Just remember, inverses are going to be going up and down. So here, let me bring it back up so you guys can actually see it. Okay, so trig functions, let's see some inverses in here. Now, if you're using Desmos, you have to use the old notation, which is arc in front and everything, but it just works just as well. So here is arc cosine, here is sine inverse, and here's tangent. Okay, and you also have to superimpose. If you go over here, and I'll show you the guys this is advanced Desmos stuff. If you go over here and you change the steps to pi for the y-axis, and you change this step to just a 1, it'll make a whole lot more sense when you're looking at it, in terms of its period and everything. Okay, and let's go light this one. Alright, so we have this all set up for you guys. I mean, everything's all interesting and set up, and there's a lot of points showing up, and I don't want them. Very interesting. Oh, they're from old points showing up. Okay. So, there you go. Alright. Some stuff's messing around with it. Interestingly enough, sine and cosine will, the inverses will match up at this number and pi over 4. If you recognize this number at all, if you do sine of pi fourths or cosine of pi fourths with radians, hint, you get that number on the calculator. It's amazing how it works, and that's always going to be how it works. So, and as you can see, if you look at sine inverse and tangent inverse, you're going to line up at 0. So those are the intersections that we're talking about. This one, not as easy as to see, and it's not going to be very common, so I'm not going to highlight it at all, so don't worry about that. But there you guys go. There's your functions. Just make sure when you are working on the project, find the exact intercepts. Don't skimp on that at all. If you're trying to find x-intercepts, set y equals to 0 and solve or factor. Identify any symmetries with respect to the origin. Just make sure you take your time and plug in negative x to see what the symmetries are. Or graph, see if it's symmetrical with respect to y equals 0. No, x equals 0, which is the y-axis. Or if it's respect to the origin, in other words, I can turn it 180 degrees and still get the same picture. That's with respect to the origin. Alright, and remember, if you're looking for points of intersection, graph the two on Desmos and see where their intersection is and see what to do with it, okay? Alright. Guys, have fun, and I'll talk to you later.